can start the session, sir.
So we were discussing about the estimation of the compound, and we have cleared about the estimation of carbon and hydrogen, and then we have done the estimation of organic compounds. So I'll give you some homework, probably if you have done. So that's pretty good. Rest, it's your choice. Now we have to go with estimation of sulfur, estimation of phosphorus, estimation of nitrogen. Okay, so let's start with the estimation of sulfur. Estimation of sulfur. See, if I'll start doing the estimation of sulfur, what you'll do, you'll again do the same thing. You will take organic compound. You will take some amount of organic compound, known amount of. You must know the amount, how much you are taking the organic compound. Okay, that known amount of organic substance is just heated with the compound what we can use, that is sodium peroxide, Na2O. Okay, or you can say, or you can write fuming HNO3. Okay, when you'll heat it inside the, and this whole process is occurring inside the carriers tube. Organic compound is heated with the sodium peroxide, or you can use fuming nitric acid inside the sealed tube, and you'll see the carbon and the hydrogen get oxidized to the carbon dioxide and water, while the sulfur in the compound get converted into the sulfuric acid. So the reaction which are involved in this process is the carbon which is present in the compound react with the oxygen. On heating, it forms CO2, while the hydrogen present in the compound when react with the oxygen from HNO3, it forms H2O. Okay, but the sulfur which is present in the organic compound will react with the oxygen, and then when on heating, it forms H2SO4. It forms H2SO4, that is sulfuric acid. And now what you'll do, you'll take the sulfuric acid. The sulfuric acid is treated with barium chloride, that is BaCl2. It will form BaSO4 plus 2HCl. Now what you'll do, you'll see the BaSO4 is a white PPT. And what you'll do, that you'll take this PPT of BaSO4, you will first filter it, then you'll wash it, then you'll dry it, and then you weigh it. Okay, so you'll get the amount of BaSO4 formed in the compound. Okay, so now we'll do the calculation part. In the calculation, what I will do, the formula I'm going to use is percentage of sulfur is equals to, the mass of sulfur is 32, and the the mass of H2, this BaSO4, the mass of BaSO4 is 233 into mass of BaSO formed, whatever the mass you have weighed, that is the mass of BaSO4 formed, divided by the mass of organic compound. See, in the starting I told you that you have to take the known amount of organic compound. So mass of organic compound taken into 100. So mass of the organic compound taken is from here. The way you have done, that will be from here. So this is the formula: 32 upon 233 into Bs, mass of BaSO4, divided by the mass of organic compound taken into 100. So let's discuss a numerical. Till now, any problem? Getting my point or not? One is speaking. Okay, very good. Okay, the question is, in sulfur estimation, 0.157 gram of organic compound is taken, which gave 0.4813 gram of barium sulfate. Okay, and the question is, calculate the percentage of sulfur in the organic compound. So how you'll do the solution? First, you'll write whatever you have the value, whatever the value is given in the question. Okay, so you can see 0.157 gram of organic compound is taken, and so the mass of organic compound, taken is equals to 0.157, first line. And how much BaSO4 is given? 0.4815. Okay, mass of BaSO4, that is equals to 0.4813. Now just put it in the formula. Percentage of sulfur is equals to 32 divided by 233 into mass of organic compound is 0.1. Mass of BaSO4 is 0.4813 divided by mass of organic compound, which you have taken, that is 0.157 into 100. Now you'll solve it. Approximately it will be 42.10%. So the organic compound which we were taking, that is around 42%. So I think not a tough question. Okay, let's discuss one more question and then we'll move for the estimation of phosphorus. Okay, question number 2. Question is 0.2595 gram. 0.2595 gram of an organic compound is taken and it forms 0.25 gram of BaSO4. Okay, so you have to calculate the percentage. Calculate the percentage of sulfur. So question is given. You'll start doing. I'm writing directly. Percentage of sulfur. Okay, how much? That is 32 upon 233 into mass of organic compound taken is given, and 0.25% is formed. That means 0.25 will come at the top, then followed by 0.2595, that is the mass of organic compound taken, into 100. So when you calculate it, it will come around 13.23%. Okay, so I'm giving you one question as homework, that is 0.2175 gram of substance is taken, gave 0.5825 gram of BaSO4 by Carius method. Calculate the percentage of sulfur. So this is your homework. Okay, let's discuss about the estimation of phosphorus. Estimation of phosphorus. So in the estimation of phosphorus, what you will do, again the method I'm going to use is Carius tube. Carius tube, we are taking Carius tube method. Okay, or Carius method you can say. What you will do, you will take organic compound which is heated with fuming nitric acid, and the tube is sealed. You will see the reactions. The reaction which occur is these. See, carbon will again react with the oxygen. On heating, it will form CO2. Hydrogen present in the reaction react with the oxygen, forming H2O. And then phosphorus present in the compound react with the oxygen, form P2O5 on heating. Okay, then P2O5 will react with 3 molecule of H2O, and on heating it will form H3PO4, 2 molecules. This is called phosphoric acid. Now you'll see one thing. From now, see, this is phosphoric acid. Till you have to do. Now there are two methods for the estimation. We have two different formulas for the estimation. Okay, so sometime what we use ammonium molybdate. Sometime we use ammonium phosphate, magnesium ammonium phosphate. Okay, so I'm taking ammonium molybdate. Then we'll see. Then I'll take so the first method I'm going to take is ammonium molybdate. Okay, so what you will do, you will take this S3PO4. This S3PO4 will react with ammonium molybdate, that is NH4 hold twice MOO4, 12 molecule of ammonium molybdate. When it react with in the presence of HNO3, 21 molecule of HNO3, and you'll heat it, it will form NH4 whole thrice PO4 dot 12 MOO3. This is known as ammonium phosphomolybdate. This was ammonium molybdate. This is ammonium phosphomolybdate. Along with it, you'll see 21 molecule of ammonium nitrate plus 12 molecule of H2O is formed. So this ammonium phosphomolybdate is a precipitate, and the color of this precipitate is yellow. You'll see a yellow PPT formed. Now again, when the PPT is formed, followed up by, first thing you'll do is filter the PPT. Second thing you will do, you will wash out the PPT. Third, then you'll do the drying, and fourth, then you'll weigh it. So according to this method, we have calculation. Okay, but first I'm telling you the second method. In the second method, what you will do, this H3PO4. Now alternative method. This is, you can say, alternative method. Alternative method. In alternative method, what you will do, this H3PO4, this H3PO4 react with magnesium chloride and ammonium chloride. Okay, they will react with magnesium chloride and ammonium chloride. They will form MgNH4PO4, that is known as magnesium ammonium phosphate along with 3 molecule of HCl. Along with the 3 molecule of HCl. On heating this phosphoric acid, which is formed in the Carious tube, when it reacts with the magnesium chloride and ammonium chloride in the presence of in the presence of heat, that it forms magnesium ammonium phosphate. Okay, now generally there is a precipitate of magnesium ammonium phosphate from that, which was white in color. Now what you will do, you will take this magnesium ammonium phosphate and you will again heat it. Okay, generally what we do, we take same process, like one more step you can do here. First, this white PPT, what you will do, you will filter it, you will wash it, again you will dry it, then you'll ignite it. This is the main thing. So I'm heating it. So when I heat this MgNH4PO4 molecule, and when I will heat it, you will see it will form Mg2P2O7 plus ammonia plus water. This Mg2P2O7, that is called magnesium pyrophosphate. Magnesium pyrophosphate. Now this magnesium pyrophosphate is weighed. Okay. Now let's discuss about the calculation process. So you got the alternative method. First method we were using ammonium molybdate. Second method we are using magnesium chloride and ammonium chloride. So let's discuss about the calculation. Let's discuss about the calculation. So first calculation, let's discuss on the basis of when we are taking ammonium phosphomolybdate. When we are taking ammonium phosphomolybdate. Okay. The calculation will be percentage of phosphorus is equals to, say, 31. First, you need to calculate the mass of this ammonium phosphomolybdate, that is NH4 whole thrice PO4 dot 12 MOO3. So the mass of this compound, 3 into 14 into 14 plus 4 plus 31 plus 4 into 16 plus 12, 96 plus 3 into 16. Okay, I'll calculate. Just give me 1 minute. Okay, so 31 divided by whatever the mass of this compound will be, then mass of ammonium phosphomolybdate formed divided by mass of substance taken into 100. Okay, just give me 1 minute. Okay. So this is coming around 1877. So that is 31 divided by 1877 into mass of ammonium phosphomolybdate divided by mass of substance taken into 100. Okay. So this is the first method. Second method I'm using on the basis of when we are taking the magnesium chloride, that pyrophosphate. Okay. And the pyrophosphate was formed. So let's discuss on the basis of Mgp2O7. Percentage of phosphorus is equals to, see, the mass of this compound is 222. That is 62 divided by 222 into mass of Mg2P2O7 divided by mass of substance taken into 100. So this is a formula. So it's two formula I'm writing just because depending upon what we are using. Generally we use is Mg2P2O7 method. Okay. So this is quite easy and you can use for this particular method. Let's discuss about some numericals on the basis of this method. Then we'll go for the last estimation, that is percentage of nitrogen. Okay. Question. Question is 0.12 gram of an organic compound containing phosphorus gave 0.22 gram of Mg2P2O7. Okay. Calculate the percentage. Calculate the percentage of phosphorus. Those who are in class right now, are you getting my point or not?
Yes, sir.
Okay. So we have organic compound given and we have the amount of Mg2P2O7 also. Now use this Mg2P2 formula. What was the formula? First, write whatever you have mass of organic compound is 0.12 gram. Mass of Mg2P2O7 is 0.22 gram. So you will start doing the calculation. So first write the formula. Percentage of phosphorus is equals to 62 divided by 222 into 0.22 divided by 0.12 into 100, and then you'll solve it. So it will be around 51.20%. Okay. So I'm giving you one question now on the same method. Okay. Just give me the percentage. I'll give you 5 minutes. Question: 0.092 gram of an organic compound containing phosphorus gave 0.111 gram of Mg2P2O7 by analysis. Calculate percentage of phosphorus in the compound, in the organic compound. Yes. Tell me the percentage within 2 to 3 minutes. Fast. You can use the calculator right now.
Is it 35.8?
35.
Yes, sir.
It's around 33.7. Let's calculate. Percentage, I'm writing right. Percentage of phosphorus, 62 divided by triple two into the amount of phosphorus, that is 0.111 divided by 0.092 into 100. Let me use the calculator first. Wait. 62 divided by triple two, that is equals to 0.2792. Okay. Into 0.111 divided by 0.092, that is will be around 1.2065 into 100. So that is 0.2792 into 1.2065 into 100. It is around 33.68%. 685, so you can write 33.7% around. Yes.
Yes, sir. It is 33.
Okay. Let me give you one more question. Same method. Okay. Now calculate 0.40 gram of organic compound. Okay. It contains 0.555 gram of Mg2P2O7. Okay. Then calculate the percentage of phosphorus. Fast.
Sir, is it 38.75?
Yeah. The answer is percentage of phosphorus is equals to that is 62 divided by triple two into 0.555 divided by 0.40 into 100. That is around 38.75%. Good. Clear this much?
Yes, sir.
Okay. Let's discuss the last estimation, that is estimation of nitrogen. Estimation of nitrogen. See, for the estimation of nitrogen, we have two methods. We have two methods. One is Dumas method. Another one is Geldahl's. Geldahl. Geldahl's method. So we have two methods for the estimation of nitrogen. So let's start. First, in Dumas method, what you have to do? Anyone know? Let me check what is in your syllabus, then I'll go for it. Here we have Dumas method. So for the Dumas method, directly just use the formula. There's a long explanation for this, and I don't think that is necessary. Just because we have to go for the formula right now, just do the formula. Percentage of nitrogen according to the Dumas. It will be 28 divided by 2 to 4, 2 to 4, 0, 0 into volume of N2 at NTB. NTB is normal temperature pressure. It will be given in the question directly. Weight of compound into 100. Okay, so I think that's not a big deal, and you can easily calculate this by this particular method. Okay, so let's do one question of this method and one question of Geldahl method. Then we'll move for the empirical and molecular formula, and the chapter will be done. Okay, so the first question I'm giving is 0.25 gram of organic compound gave 31.1 ml of N2 by Dumas method. Okay, and question is calculate the percentage of nitrogen. So just use this formula. Volume is given, weight is given, tell me the percentage. Fast. Yes, what is the percentage? See, the formula is 28 divided by 2
So
to 4.
15.55.
15.5, sir.
55.
Yeah,
15.55.
15.5. 31.1 divided by 0.25 into 100. That is equals to 15.55%. Okay, yeah, good. Now let's discuss about the Geldahl method. Okay, so what happened in this particular compound? Just give me 1 minute, I'll show you the diagram. Wait, just give me 1 minute. Yes. Is this image is visible? Yes. Am I audible?
Yes, sir.
Yes, sir.
This image is visible, no? Okay. So let's understand this image. Yes. Okay. So in this particular, see, you can see the first one is known as Gildhall flask. In the Gildhall flask, what you will do, you will add the organic compound. Along with it, you'll add concentrated H2SO4. Okay. Then some amount of K2SO4 and copper sulfate. You'll heat it. Okay. Now the extract formed here, whatever it is formed is known as this gel-delized solution. Now this particular solution is then added with the NaOH, and when it react with the NaOH, it will form ammonia along with the water steam. Okay, or you can say simply steam. Okay, now this ammonia will go further along with this steam on this particular condenser. This is a condenser over here, and here the from the tap it will cold water will come here, and to the sink it will go hot water, and there's a condensation process occur here. This is condensation, and you'll see after the condensation we have a amount of known amount of standard acid. It's a sort of titration. So this is a particular way to do the Gildhall process. Now the reaction what are involved in this particular reaction, that you can say process is the nitrogen which was present in the nitrogen organic compound will react with the concentrated H2SO4, and it will convert into ammonium sulfates. Okay, this ammonium sulfate again react with two molecule of NaOH, and on heating it will form Na2SO4 plus 2H2O plus NH3. Okay, now this NH3 will react with H2SO4 and will again form ammonium sulfate. Okay, so or this is a sort of you can say acid base mixture. Okay, but the volume of acid which is left, the volume of acid left unused is titrated against strong alkali. We'll do the titration against the alkali, that is base. For example, H2SO4 is remaining in the reaction and we are using it, and it will react, do the titration with the NaOH. I'm taking alkali along with the H2SO4, it will form Na2SO4 plus H2. So this is a particular way. That's not important quite, but the numerical of this particular is important. Okay, so for example, I'm taking a percentage of nitrogen is equals to, okay, not the question, formula, sorry. Percentage of nitrogen is 1.4 into molarity of acid, which will be given in the question. Then basicity of acid into volume of acid used divided by mass of substance taken. Or you can use percentage of nitrogen is equals to 1.4 into molarity into volume of acid used divided by mass of substance taken. But in this condition, the basicity of acid is considered as 1. And One more good thing is what percentage of nitrogen is 1.4 into normality. Sometimes normality is given in the question. Into volume of acid used divided by mass of substance taken. You can write the formula. Just note it down in your copy so that I can do the numerical. There's because 3 formula I have taken. Done?
1 minute, sir.
Huh? Noted?
1 minute, sir.
Okay, just 2. Yeah.
Yes, sir.
Done? Okay. Let's do a numerical. Question is, during estimation of nitrogen, an organic compound by Dildal method. Okay. So it must be mentioned in the question, Dildal method. The ammonia evolved from 0.5 gram. This is the mass of organic compound. Okay. 0.5 gram of compound neutralized by 10 ml of 1m H2SO4. Find the percentage of nitrogen. Yes, first of all, the formula we'll use is the, see, 1m condition, yani molar concentration is given. So whatever is given, just write out. Mass of organic compound, mass of substance taken is given, that is 0.5. Okay. Molarity of the acid is given 1m. Okay. And volume of acid used is given. How much is used? 10 ml. What else? Basicity. Basicity of H2SO4 is? What is the basicity of H2SO4? Anyone knows what is basicity? No one knows. See, H2SO4 when dissolved in water, it gives out 2 molecule of H3O positive plus SO4 negative. Okay, so just because 2 molecule of H3O positive is given, that's why the basicity of the compound is 2. Okay, if for example I'm talking about HCl, it only gives out 1 H3O positive. It means 1 hydronium ion is furnished, so it means the basicity is 1. 2 hydronium ion, basicity is 2. H3PO4, 3 hydrogen is present, so 3 hydronium ion will form. So it will form 3 the basicity will be 3. So now basicity is given also, so it is 3. So let's take the formula. That is percentage 1.4 into, what is the volume of acid used? That is 10 into basicity of the acid is 2 into molarity of the compound is 1 divided by what is the mass of organic compound taken, that is 0.5. So when you'll do it, the calculation, it will be around 56%. Okay. Let's do one more numerical based on the normality. Okay. Question is given 0.50 gram of organic compound is taken and by Jidhal method. Okay, I'm not writing now. And NH3 evolved was absorbed by 1n H2SO4 normality दी है, that is H2SO4. The residual acid requires 60 centimeter cube of N by 2 NaOH. Find the volume of 1n H2SO4 taken. Here we have to calculate the volume taken if the percentage is given. Percentage is 56. Now how you'll do? First you will see, you'll assume the things. So we are taking, let 1n H2SO4 volume is V. Okay. And we know that 60 centimeter cube, or you can write 60 ml. 60 ml of N by 2 NaOH have 30 ml of 1N NaOH. If I talk about one, or you can write 30 ml of 1N H2SO4. Just because we know for the neutralization, if 1N NaOH, so for neutralizing 1N H2SO4, we require the same normality. Okay. And second thing, for example, I'm talking for 60 ml, it was N by 2. For 1 N, I'm using, it is 30 ml. So volume is left with the volume left unused. So that will be equals to 30 ml. And volume of acid which is used, that will be around, we don't know, just because we don't know this V. So just imagine this is the total volume. So if the 30 is unused, so we can write V minus 30. If the 30 is unused, so what I'm doing, see, from the starting, see, 1 and H2SO4 I've considered as V. 60 ml of N by 2 NaOH. If I'm talking about 1 N NaOH, so I'll do the half. 60, half is 30. So 30 ml of NaOH is used to neutralize a 30 ml of 1MH2SO4. So the initial concentration I don't know, so I'm considering that as V. And if the 30s remain unused, so I'm writing 1 minus 30, or you can say V minus 30. Now when I'll start doing the percentage calculation, it will be 1.4 into what was the formula? Normality. Normality is given 1N. So it will be 1 into, that is volume of acid V minus 30 divided by 0.50. Okay, just write the percentage is also given in the question. So I will write the percentage given as 56. So it will be 56. So when you will do the calculation, okay, so it will be 56 into 0.50 divided by 1.4, which is equals to V minus 30. When you will calculate it, the V will be around 50 ml. So rarely this kind of question is asked, but at least just do for 3 to 4 questions from your book, you'll get it. It's not that much tough, but you can do it. Okay, just revise through it once. The last thing what is remaining in the chapter is the calculation of the empirical formula and the molecular formula. Do we have time? Yeah, we have. So we'll start with the calculation of empirical formula and molecular formula. So first of all, what is the empirical formula? See, empirical formula is that formula which gives the simplest whole number ratio. Which gives the simplest whole number ratio. Okay, between the atoms, what are the ratio? It will tell. While for the calculation of molecular formula is the actual number, you can say. The actual number of atoms present in the molecule. That is, actual number is molecular formula, simple number ratio is empirical formula. So for the calculation of molecular formula, from the empirical formula, we'll use one formula, that is molecular formula is equals to n into empirical formula, where n is equals to integer. N is equals to integer. How you'll calculate the n? It will be molecular mass of compound divided by empirical formula mass of the compound. In some cases you'll write this, and some cases you can write 2 into vapor density. Sometime in the question vapor density is given, so 2 into vapor density divided by the empirical formula mass, same whatever in the down. So just remember this question, this thing, and let's start with the question. So first question, let's take, okay, the question is given. The question is a diabasic diabasic organic acid have carbon is equals to 34.62%, hydrogen is equals to 3.84%, and oxygen is equals to 61.54%. Okay, so this is given in the question, and if the question is calculate empirical formula and molecular formula. Calculate the empirical formula and molecular formula, and molecular mass is also given. Molecular mass is given, that is equals to 107.50. Okay, so now you have to calculate the formula. Sometime the molecular mass is not given, so you also need to calculate the molecular mass. So that will be quite typical. Sometime it will be typical. What you will do, you will see what is the mass is given, what is the mole given, what is the percentage given, then you have to calculate the molecular mass also. So in this case, let's make a table. So what you have to do, first you will write the elements. For example, element carbon, hydrogen and oxygen. Percentage of the elements is given, that is 34.62% carbon, hydrogen is given 3.84%, oxygen is given 61.54%. Then atomic mass is given, or if it is not given, you have to write carbon mass is 12, hydrogen mass is 1, oxygen mass is 16. Then what you have to do, you have to calculate the relative number of atoms. Relative number of atom. For relative number of atom, what you will do, you'll write that is percentage divided by atomic mass. Percentage divided by atomic mass. So percentage is 34.62 divided by mass is 12. Percentage is 3.84 divided by the mass is 1. Percentage is 61.54 divided by the mass is 16. So you'll calculate this, it will be around 2.88, it will be around 3.84, it will be around 3.84. And last step is simple whole number ratio. So for calculating the simple whole number ratio, you can see one thing, that what you will do, you will see the relative number of atoms. See 2.88, 3.84, 3.84. You'll write the smallest one. From the smallest one, just divide all. So the smallest one is 2.88. So it will be 2.88 divided by 2.88, 3.84 divided by 2.88, 3.84 divided by 2.88. So when you'll divide it, it will be around 1, it will be around 1.33, it will be around 1.33. So for this, making it an actual whole number ratio, in okay, not in point. So you'll multiply them to a number so that it can form a whole number. So now I'll multiply it by 3 by 3 by 3. So it will be 3, it will be around 4, it will be around 4. So carbon we have, see carbon we have how much? 3. So it will be C3. Hydrogen we have 4. So H4. Oxygen we have 4. So it will be O4. So this is the empirical formula. C3H4O4. Got it? Yes or no? See, first elements, then percentage, then atomic mass, divide percentage by atomic mass, you'll get the relative number of atom, then pick the smallest one, and then divide this divide all the relative number of atom by the smallest one. And for converting into the whole number ratio, you have to multiply it by any of these. Sometimes you'll get directly the whole number ratios. If you're not getting the whole number ratio, then multiply each term by the same number so that every number get converted into the whole number. Okay. So just calculate the mass of this 12 into 3 plus 1 into 4 plus oxygen 16 into 4. It will be around 104. So this is the empirical formula of it. So now calculate the number of N. How you calculate N? Is 107.50 divided by 104. Mass is given in the question. Empirical formula mass we have calculated, so it will be around 1. So the molecular formula is N into empirical formula. The value of N is 1. Empirical formula is C3H4O4. So the molecular formula will be C3H4O4. So this is the molecular formula. Any doubt in this empirical formula and molecular formula? Yes. Any doubt?
No, sir.
Easy, na? This is easy. I think you have learned this. If anyone is belonging to 11th, that ICSC ever. So in ICSC book and in the 11th CBSE book and also in the state boards book, it is given in the first or second chapter. I think you have already discussed this thing. So we had this thing and now we have finished the one more chapter of our syllabus. So total, if I'll say, I have completed 4 chapters now. And let me tell you, first I have done the chemical bonding. Then we have done for the same basic principle of organic chemistry. That was the biggest chapter. Then isomerism we have done. Then purification, the characterization of organic compounds. Okay. So see, in the mid, what we can do now, we have the thing which is left as hydrocarbons. So I just want to ask you, should I go with the hydrocarbon or you just want to take a short break for from the organic? If you want to take a short break, then I'll move for the environmental chemistry first. And then I'll go for the hydrocarbon. So just tell me whatever your decision, I'll do the same. If you want to continue just because we are doing the organic, so it will finish first. So two method, if you want to finish the organic first or else you want a break from the organic, then you'll again start the organic. Yes, what you want? Yes. What do you want? Gayatri, Vignesh, Shivani, Ashrita, Noshin. What should I do? Should I continue with the organic?
Yes, sir.
Okay, should I continue? Yeah, I'll continue then. The rest are okay with the decision?
Yeah, sir.
Okay, so we'll continue with the organic. We'll do this. We'll start the hydrocarbon from the next class, and probably hydrocarbon will take 6 to 7 classes. Okay, so probably in 1 week I will complete this hydrocarbon. If I'll get an extra class, then we'll complete this fast. Then later on, the organic chemistry and the hydrocarbon is finished. Then we'll discuss the next chapter what we have to teach. Okay. So see you in the next class. You can join the next session. Have a good day. Thank you so much.
Yes,